Double Dragon 3, the Rosetta Stone.
Hi guys, I'm back with another arcade PCB repair, and today on the bench I got a Double Dragon 3 PCB, a very nice game which was made by Technos Japan in the early 90s. I got this board off of eBay and I bought it as working, but unfortunately it turns out that this PCB is suffering from some graphical issues. I just took it out of the package and hooked it up for a test, and I noticed some graphical issues on the title screen and some missing graphics in the intro, but I'll show you in a moment. The purpose of this video is, as always, to go through the troubleshooting of the issue step by step and try to fix the board, and maybe or hopefully you learn something on the way. So, well, let's start by looking at the problem that we are facing. And first thing you notice is that on this screen you see Billy and Jimmy, and Billy's graphics are obviously missing. It's all black. That is not supposed to be the case, I think. And well, this looks quite right actually, but when the title screen is coming up, you will notice that the graphics, the Double Dragon 3 logo obviously is being shown in the wrong colors. The game gets into demo mode now. Everything is working fine. Apart from the graphical issues, you can play the game and the in-game graphics look okay. But there seems to be some kind of graphical flaws, at least on the title screen and in the intro. So that's what we're going to be looking into now. Okay, so what could be causing the graphical problems that we're seeing on the screen? Well, I thought it was quite easy, and my first feeling was this could be some sort of a problem with an EEPROM which stores the graphical data, because as you can see, the game is obviously running. Most of the graphics seem okay, the sound seems okay, the gameplay seems okay, so most of the circuit is on this board is obviously intact, but there's some graphical data that is obviously glitched up for some very limited areas in the game. So it would be a good conclusion to make that maybe there's a problem with the graphics EEPROMs. And where on this board are the graphics EEPROMs? Well, unfortunately we don't have schematics for the Double Dragon 3 board, but that's not a big deal, because as you can see on the board, maybe there is 3 regions, I'd say, of EEPROMs on this board. First region would be over here. You see 2 EEPROM chips here. They are situated next to the main CPU, which is a Motorola 68000 CPU. Some more EEPROMs here, one over here and one over there. This here is probably the sound CPU that is located next to this EEPROM here. And we have a larger bank of many EEPROM chips on this side of the board. Some of those are socketed, others aren't socketed. Those are probably the EEPROMs that are storing the graphical data. How do I know that? Well, that's also pretty easy, because those two, which are located next to the CPU, will probably be containing program code, because that is what the CPU needs to be able to access very directly, the program code. and that goes also for the sound CPU. So this will probably be the code for the sound CPU. This, which is sort of located in between the sound CPU circuit and also the sound output circuit with the amplifier, this will very likely be an EEPROM which is containing some digital sounds. So those EEPROMs are left, and they are probably storing the graphical data. Those EEPROMs and the data they are containing are not necessarily do not need to be addressed directly by any CPU necessarily. They are mostly being accessed by the circuitry that generates the background, the sprites, and the text on the screen. So just judging by the position of the EEPROMs on the board, you can pretty much tell what EEPROMs are containing what kind of data. Okay, so the first thing I did is and I already tried that, I took a screwdriver like this and I removed one of those EEPROMs, which I suspect to be graphical EEPROMs, from the socket. And you can actually see that the graphics are changing. You know, the background here, for instance, has turned green, and behind this text over here. So maybe this is some graphical data for the text overlays that this EEPROM is addressing. When I put the EEPROM chip back, the text overlays are okay again, so I don't really think that this EEPROM has anything to do, unfortunately, with the missing graphics and the glitched up graphics on the title screen. I also removed those other three EEPROMs from their sockets, and I didn't get any effect on the glitched up graphics. They just stayed the way they were, and those other three also only pretty much affected the text on the screen. So these four EEPROMs probably cannot be the culprit for the graphical problem that we're having. So what remains is those four EEPROMs in between, and also those four EEPROMs over here, which could contain bad data. It is a bit difficult to test them because they are not socketed. So, and just when I thought it could be getting difficult, like I would have to use the logic analyzer on the board, or would have to socket all those EEPROMs to be able to test them, I actually found something very peculiar. When I was moving the board, let me show you if I can reproduce this. Let me just coin up the game so we're getting on the title screen. Yeah. Okay, so if I just pick up the board on one corner and sort of like move it up, and sometimes you can see it now. What did I do? I just did this and I pressed a little on the board, and you see, oops. So on off, on off. What am I doing? Just wiggling with the PCB, and the glitch is coming and going. Very, very interesting, and this is pretty much a major clue already. Okay, so what does this finding tell us? Well, it pretty much tells us that we are probably not facing a bad component on this on the PCB, but there's this is rather a problem with a bad connection, and at some point, and if I move the board, or if I twist the board slightly, the loose connection seems to make contact from time to time, and actually the game shows the correct graphics in this situation. So we are dealing with a broken connection, obviously, and there's actually three possibilities now where the connection problem can result from, and in the order of probability, I would say first thing would be a problem with a socketed chip, maybe with the socket itself, or maybe with the legs of the chip, which could be corroded, or the socket could be corroded. So it is making an intermittent connection on one of an IC's legs. This is something that is very probable, and that you find a lot. I already had this problem in, for instance, my Roadrunner PCB repair and my Indiana Jones repair, which you can also find videos about. The second possibility, I would say, and we had to deal with that problem also several times before, would be damaged traces. If somewhere on the board there's a cut trace, it is also possible that by slightly bending or moving the board or twisting the board, that a cut trace, which might have a very slight cut, can make contact depending on you bending and twisting the board. That would be the second possibility. And the third possibility, also possible, I don't know if we have encountered that before, I don't think so, but you can see it from time to time. It's the possibility of a cold solder joint, and that means that components that are usually stressed on the PCB, maybe something like edge connectors, ribbon connectors, which are mechanically stressed, may lose connection in their solder points, and there might be cracks in the solder appearing, and that might also cause position dependent, so to say, issues with the board functioning. Okay, so let's just go through the possibilities that I just talked about, and the first thing would be problems with the sockets, and we already tested those, I already removed all of those EEPROMs, and they look like minty new and very, very shiny clean, and so do the sockets, which is, for instance, very, very different to the Indiana Jones PCB and Roadrunner PCB that I mentioned before. Those sockets were really messed up and corroded. These are like minty clean, and I don't have any suspicious sockets on this board. Apart from that, removing those chips didn't change anything with the graphical glitches in question. So I think this is not the case. This is not the problem on this PCB. Also, no other relevant chips are really socketed, which are concerning the graphics on the screen. So in this case, it doesn't seem to be the problem. So the second thing I mentioned was the damaged traces, and you can just see by flipping the board up, it sometimes works also. So you really have to inspect both sides of a PCB really very closely and look for minor damages, like you see here, those scratches here, if they might have affected some of the traces. That is very well possible. Here's actually some scratch that looks a bit deeper. I think I will have to look at that more closely. but other than this scratch I don't see anything. Yeah, but I think we should look at this one over here more closely. Okay, so you can see the scratch here under the microscope with a magnification of 10, and you can see that it's actually going across a trace on the PCB, and it has scratched the protective coating from the trace. So you can see the copper in the center, but it doesn't look like the trace has really been cut. It should still be okay. We can test it just by doing a continuity test with a multimeter. Let's just go ahead and do that. So, okay, let's see. The trace is going from this guy to this one over here. Okay, and we do have continuity though, so I don't think there is really a problem. I could also try wiggling the board, but no, I don't think that this is really a problem. Okay, so I didn't find any trace damage on the parts side of the PCB, so that pretty much leaves us with a cold solder joint possibility. Well, what you can always do is try to find a certain location on the PCB or a certain region in which the mechanical manipulation of the board is affecting the glitch that we're seeing on the screen, to sort of narrow down the area where the problem could be coming from. And that is what we're actually going to try now. Okay, so let me see if I can find any region that could be problematic. I'm just grabbing the... Okay, if I press here, the graphics, okay. So if I'm pressing on these EEPROMs here, I do get the graphics. If I let go, the graphics are glitchy again, so this is interesting. Also, no, not so much here, but more over here. And, well, yeah, but also touching the region over here. Okay, but not so much on this side, obviously, so we got to be somewhere around here. Okay, this. Okay, what you can also check is if the area is actually quite large, like at the moment. You can see how much force you actually need to apply to a chip or to a location on the board to make the difference. And it seems like actually if I touch this, unfortunately this custom IC over here very lightly, I'm actually triggering the issue, and I don't think that I'm really bending the board at the moment or anything. Yeah, that is very suspicious. So this is a larger custom chip which is surface mount, and those ICs can have cold solder joints actually. I saw this once on one of my Daytona PCBs. Okay, well, just let's look closer at that IC. Okay, here's the IC in question. and it doesn't really look too suspicious on the first glance. There's no signs of corrosion or anything, but I just noticed something very interesting, which I'm going to show you right now. And that is, if I, with my fingernails, move around the IC and press down on the little legs that are coming out the side to force them towards the PCB, I don't get any effect if I'm doing this on this side. I don't get much over here. Well, it's flickering a bit over here, but I have to press quite strongly. I don't get much over here. But on this side, especially on the end here, you know, the slightest touch makes a difference. So maybe we can look at these contacts under the microscope and see if we find anything. Okay, so this is the top row of pins that I was testing before, and well, the job that was done at the factory when they soldered this IC on the board wasn't really too much of a good job. I think there's you can see there's a problem with a slight misalignment of the IC. It's actually too far to the right, and if you look at the pin that is farthest to the left on the image right now, you can maybe see that it is really misaligned, and half of the IC pin isn't even touching the pad. So maybe I don't think that those pins were making a good connection in the first place, really. Maybe I can show you some images of how those soldered pins are actually supposed to look like. Okay, so maybe as an example I can show you one of my Daytona PCBs. So what I mean is, what you maybe can see here is that the IC pins are really connected to the pads, and the pads really have a decent amount of solder on them, and you can see that the IC pins are kind of flowing into that solder and onto the pad really, and you don't really see this much on the Double Dragon board. You have more the impression that the legs of the ICs are hovering above the solder pad, and you don't really can see any solder connection. So I think what I'm going to do is I'm going to completely resolder the IC on the Double Dragon board, and we'll see if this fixes the issue. It probably should. Okay, here's the result after adding some solder and reflowing all the pins. The pin on the left, you can see I added lots more solder, I think this might be the pin that was mainly problematic, but I reflowed all the other ones. I tried to press down the pins with a very tiny screwdriver while I heated them, so they get good contact to the PCB. Sorry about that. Okay, there we are. And well, let's just hook up the game and hopefully the issue is fixed. Let's see. Okay guys, so here's again the moment of truth. Don't you love it? Let's see if the game is working. Whoops. Not so much. Well, I guess we made it even worse. So maybe I bridged some of the contacts, so let's take another look at the IC. Okay, so I found two problems with my resoldering job. Well, if any of you guys is really good at soldering very small SMD components, you will probably be screaming anyway. I don't really have very good equipment to solder those kind of parts. But well, I did find two problems. One pin wasn't really connected very good and was still floating when I tested it with the multimeter. And also at one location I did accidentally bridge two of the pins that were next to each other up here where they are entering the IC. So I removed those problems, and I think I tested all the pins through with my multimeter by doing a continuity check between the pads and the IC's legs on top. So I think there should be no more unwanted shorts and everything should have good contact. So let's give it another go. Okay, so again, moment of truth number 2. Okay, that looks much better. Alright, Jimmy is back. And we will have to look at the title screen to see if we are good. And ta-da! Looks great. So if I wiggle the IC now, or if I move the board, doesn't really do much. So I think the issue is fixed. Great. So thank you very much for watching this video. If you like this video, you are of course free to watch some of my other arcade repair videos. I hope that my videos can help you fix issues with your games, to keep your arcade PCB collection running. And well, of course, you're also very welcome to subscribe to my channel. So again, thank you very much, and see you next time.